Hello everyone and welcome back to another video. Now here we have two new graphics cards and I've bought these together for 40 euros on eBay and they were both described as dead. Now the 780 over here, which is a Windforce 780 from MSI, like it came with the red, black twin Frozer cooler, but it is a reference PCB 780. And then we have here this Asus card, which is a 680 and also uses the reference PCB. And yeah, so usually I don't buy dead cards unless I know that, unless I specifically know what's wrong with them and how I'm gonna be able to fix it. Now for the 680, I had no idea what was wrong with it. For the 780 I did. So as you can see here, there's there's kind of a hole in the PCB, and this is a very common thing that happens with 780, 780 Ti, 980 Ti, Titan, Black, Titan X, the Maxwell 1 PCBs, because all of these use pretty much this PCB. It's a 6-phase with, at least on the 780 Ti, it's an NCP 4206, 6 phases of FDMF 6823Cs, if I remember correctly. And pretty much the only major difference between the 780 and the original Titan to the later ones is that the later ones added 2 more power stages. It's not 2 more phases, it's just 2 more power stages, because those essentially act as switches for power balancing. Those are still a 6-phase, so this 780 does only have 6 power stages, whereas the later ones have 8, but still only 6 phases. Now this card actually came with some SiC DR MOSes instead of the FDMF ones. I haven't looked them up because I was just gonna remove them anyway, which you can see I've already done. So the thing is, one of these DR MOSes or power stages blew up, and it put the deep hole into the PCB that I just showed you. Now that's a pretty, like I've said, that's a pretty common thing on these PCBs because they have rather weak VRMs. So if you have a reference PCB 700 or 900 series card, the 600 series seems more robust, because those are using discrete MOSFETs, not like DR MOSes, and discrete MOSFETs on average have like a higher current handling capability, and it's like easier to cool them because you have like 3 separate heat sources for a standard VRM, whereas here you just have one chip. Yeah, so the thing that happens is these DR MOSes or power stages blow up a lot. Because like the card is stressing them pretty much to the limit, and then they also, like, there's a very few PCBs, like reference PCB cards, that have good VRM cooling, so they also run pretty hot. It's actually like EVGA 980 Ti's, I think it's the SC cards, like the dual fan ones. EVGA 980 Ti's use the reference PCB, and I've seen, I think, 8 of them where the bottom DR MOS, which is one of the power balancing ones, I think, blew up and pretty much also tore a hole into the PCB just like this. So yeah, the way how you would, if you were a professional and would repair the card properly, what you would do is you take a Dremel and you drill into the PCB until the scorch marks are gone. You will not put this power stage back on. So in best case, this card ends up running with a 5-phase, which is even worse because then it has an even higher chance of blowing up again. But yeah, that's like the proper way if you want to keep the card as like a normal card. What I'm doing is the extreme overclocking variant of that, which is, so the VCore VRM is shot. Well, let's go around it, because I'm gonna put my e-power on this. I've previously tried e-powering a 580 reference card. That mostly worked, like the card put out an image, but it was extremely unstable on the memory, which I don't exactly know why. It could be that I damaged the memory trace. I got pretty close to them when I removed the solder mask. It could be that the e-power, because I e-powered on that card both core and memory, could be that the e-power portion that does memory is just not that great. So I don't know why it didn't work out. It just like, it kinda worked, it just didn't run benchmarks at like high memory clocks, or even stock for that matter. I had to lower memory, then it ran fine. So on this card, the memory VRAM is still here. Sadly, it uses these inductors, which is another common fault on these PCB. So this specific type of inductor, there's like a slightly different one, but like this style of inductor, they like to burn out a lot as well. So there's a lot of these cards that have like these inductors like blow up, because they're also very much at the limit. They have like, these are pretty much rated at the current that they're being used at. So any more current than that, and yeah, at some point they're gonna burn out, so yeah. But I guess for now it's fine. Like, most of my cards just see a bench from here and there, like it's not daily usage, so the load is much more sporadic, and I hope that will keep it alive. Well, like, swapping these inductors wouldn't be that hard, it's just the e-power is gonna be in the way. So it could be potentially annoying. But for now the VMEM VRM stays, I'm just doing core. So to do that, I have also removed the PWM controller already, and one of the 12 volt input inductors, because this is connected to the 8-pin, and so the 8-pin powers, I think, these 3. It could be that it's doing like these 4, and then like I don't know. So this is the input inductor for the 8-pin, and I've removed that because that's where the short is. Because even though the power stage is removed, there's still a short in the PCB, which is why you would drill into it if you do it properly. So there's still a short from 12 volts to ground in there, in that blown up part of the PCB somewhere. So what I'm doing is, yeah, I'm again going around it, so I'm cutting off 12 volt supply to this power plane, which I hope nothing else is connected to. Like, PEX is down here, memory is here. If these are connected to the same power plane, that will be a problem, but I think these are both on the PCIe. So, yeah. Yeah, so the e-power is going on to the core over here, and then this card should work again. So yeah, then I have another 780, like I have the Jetstream, then I have this 780. I could potentially run them in SLI, but the Jetstream also still has like the power stage that's pretty much about to die. And this all started with me considering to e-power that one. But the Jetstream first has a really good core that I don't want to risk, and also it has through-hole inductors, which are just a pain to remove. This one has SMD inductors, so I just take the heat gun and then they're gone, because the heat gun just melts the solder in seconds. So yeah, I'm gonna be e-powering this, and I just hope the core is good and the memory is good. So the memory on this is Hynix AFR. Samsung would be ideal, just like any kind of... I don't know what revisions of Samsung memory are on Kepler cards, but I've heard it's just better than Hynix. But Hynix AFR I have on my HD7970 Matrix as well, and there at least it's scaled with voltage. So yeah, so 2 gigabit. This is 2 gigabit Hynix AFR. I had it on one, like, pretty much everything I know about it is it should scale with voltage. The Jetstream also has AFR, so yeah. And that's pretty much the plan for this 780. I've already repurposed the heatsink. The heatsink from this card is now on my Zotac 780 Ti, because the Zotac card, well, I mean, the heatsink from this card wasn't that great either. It just has 4 heat pipes, but like it has a lot more airflow going through to the memory and VRM, and also I tested it and it like barely touched 60. So that's on the Zotac card now. Maybe, well, the Zotac cooler doesn't fit this one, but like I'm e-powering it, so this will pretty much have a water block all the time, because the only other heatsink that I have that fits is like not really that substantial and like probably not powerful enough. So this is pretty much only gonna be on water. So yeah, so that's for the 780. Then for the 680, this one kind of works actually. So I tore this down and realized that this was never disassembled before. The 780 actually, this one came with this inductor and these two power stages removed, and also had like solar flux residue on the PCB. This one was clean. This one wasn't messed with by anyone. So like, yeah, the screws are really hard to take out, and then the thermopaste looked very much factory. And the thermopads were not like, this has these sticky thermopads that just tear when you take the heatsink off, and those weren't torn before. So yeah, no one disassembled this card. From the same guy though. Yeah. So this 680, I've had it put out an image already, but I haven't had it boot to Windows. So I went over the PCB, like there's no visible problems with it. There's like, yeah, pretty much nothing. It's even pretty clean, like there was only a little bit of dust in the heatsink. So this is in pretty good condition actually. So I went with a multimeter to check for shorts, and I actually found one. So this card has 1 ohm resistance on the memory rail. Memory is usually 20 to like 100 ohms. This has 1. So I was like, okay, VMem seems to be pretty much shorted to ground. Like, why can that be? So, yeah, I've had this before, a similar thing. So first I thought one of the low sides is gonna die. Because I thought that because the 580 Lightning that I amputated 2 V-core phases of, that one also had a reading like that, just from 12 volts to V-core, where like it pretty much showed a short, but the card still ran. So I was like, okay, maybe one of the low side MOSFETs, because that was a MOSFET on the 580. It was like a MOSFET that was shorted when turned off, but when like gate drive was applied to it, it seemed to work, like the card ran. So I thought this has the same. So I was thinking about removing the 2 low side MOSFETs in the memory rail, because I couldn't really find out which one it is. And as I was pretty much preparing to do that, I ran the card, tried to run it, never booted to Windows. I just by chance touched the back of the card in this area and immediately burned myself, because one of the capacitors on memory chips right here is shorted, or pretty much shorted. Like shorted so much that it heats up a lot. Actually, I think you can see it here, this whitish thing, that's the burn mark. So I'm not quite sure which capacitor this is, but I think it's this. I've marked this with like blue paint, because I think this is the capacitor. I'm not 100% sure though, like I'm not really trying to burn myself, so it's kind of hard to find out which it is if you can just like touch and see if it's hot. I think it was this one. So what I'm gonna do is remove this, and then we'll see if the short is gone. And then I will potentially, like, that's not everything, that's just part of what I harvested from other cards. So I'm just gonna take a capacitor and put it on. And then this should work. Which, yeah. So I've had a 670 for the win previously. This 680 is pretty much the same PCB, just with a 680 core instead of a 670 core. So yeah, it's a 4-phase V-core, 2-phase memory. Nothing exciting, but seems to work. And there's also a lot of modding headroom. So we have these spots right here. Like these two spots on the 670 were actually not populated. These, yeah, like I can populate these with all the capacitors. And then on the front there's also 3 empty SMD polymer spots for the memory, which I can also populate. So I can put some extra capacitance on this without like making it super annoying to work with, because if you sort of like can type capacitors to the back of graphics cards, you can't really put them down on the table like this anymore, which is potentially annoying. So yeah. So it's pretty much like I am set on how I'm gonna make these two cards work. This one has a higher chance of working out because it's literally just remove a capacitor and maybe put it back on. Like I've had 480, I have a 480 which has several of these capacitors knocked off and I just didn't care. But I've also seen cards where you knock off one of these capacitors and it won't run stock stable anymore. So I guess I'm just gonna put it back on because doing things properly is good, I guess. So yeah, if it's this capacitor, which I hope it is, just remove that, put a new one on, and then this 680 is completely functional, which is nice. Because originally I just cared about the 780. So basically, like, I paid $40, which is kind of a lot for a dead card, but I knew exactly what's wrong with it, because like there was a good picture of this area in the listing. So I knew what problem this card had. I knew it's e-powerable, because like cards, like there's not really two problems at the same time. If something's dead, then there's 99% of the time one problem, and this is the problem of this card. So I know how to deal with that. It's just disconnect the 12 volts power plane and e-power V-core, and then it works again. There is a chance that this core is dead though, because like this is the high side blew up. I'm pretty sure this is the high side part that blew the hole into the PCB. And yeah, like it blew a hole into the PCB. So the person that was using this card had a very slow power supply. Like my power supply in my test bench would just immediately cut the power before anything gets hot enough to like even like burn. This obviously burned a hole into the PCB, so the person that was using this card had a very slow power supply which kicked in not fast enough to stop this thing from catching fire. Which means that there was probably an extended amount of time where 12 volts was getting through the power stage to the V-core output. Which, if the voltage went high enough, like there's still an inductor there, so it's not instant 12 volts, it's like rising very rapidly, the core might be dead because too much voltage. I don't think it is, because like all those 980 Ti's that I was talking about, like 980 Ti reference cards are really popular on repair channels, especially on German repair channels. There's like a couple German video card repair channels, and all they do is just 980 Ti reference cards, and like 2/3 of them are the EVGA card, because that one had not just the very bad reference PCB, but also very bad VRM cooling, so that one ran hotter and like blew up more. But yeah, like this is pretty much the same PCB, pretty much the same problem, and all of those 980 Ti's that I've seen worked in the end. There was even one which had an even worse hole in this. Actually, it was the exact same power stage, just it had these two extra ones for current balancing. But yeah, I saw a 980 Ti XC EVGA thing that had pretty much this exact power stage also blow a hole in this exact spot. Just worse, like there's nothing on the back, like the back looks fine. On that 980 Ti the back was very much not fine, and in the end when like that one was a proper repair by a proper repair person, and they drilled a hole through the PCB so you could look through the PCB in the end. So I'm not gonna do this here. And my hot station just fell from the desk. Yeah, so it's pretty much the plan. I am looking forward to this. This was the main reason I wanted this kit. Like the 680 was just a bonus in my opinion. And because there wasn't any indication that something was wrong with it, like this wasn't run through an oven, because if you run cards through an oven, these stickers here, which are on all the reference PCBs, they like warp and contract. This sticker is still fine. Same for the rubber pads on the back here, so neither of these cards went through an oven, which is a good thing. So I was like, the 680, since there's nothing like burnt on it, it's probably just a reflow the core and done job. Didn't end up being that, ended up being a capacitor removal job, but that's pretty much the same difficulty. And then this, yeah, I knew going into it that's gonna be an E-Power job, but I was looking for a use of my E-Power 5 anyway, and this is gonna be a great start. Because like I was so close to E-Powering the Jetstream, it's just like, that PCB is harder to work with, and if I kill the card, I'm losing what is possibly my best. I mean, it is my best Kepler core, because it's like outclocking everything else I ever tested on GK110 by a lot. Admittedly, I ran a lot more voltage into that card, but yeah. So this is pretty much a test run, if I ever eventually like try to E-Power the Jetstream as well. But if this works out, the E-Power 5 will probably stay on this, because this core can pull a stupid amount of power, which, like, one of the 580 power boards, which I also have one free to use, I mean, it will work, but like it will be barely better than the stock VRM, and I want to overclock this like a lot. Like, if I connect an E-Power, I have voltage control anyway, and it looks completely disgusting. Like, oh, I mean, E-Powers look nice, but not in the same way that properly made cards look. So yeah. But I think the E-Power 5 is a good fit for this. I don't think I'll be... Like, I'm gonna try to get VMEM working. If it doesn't work out, I can just E-Power it also. But yeah. So I hope this will be very interesting. And if the E-Power works out, this is... Yeah, I think if the E-Power works out, this is gonna be... because this is probably gonna become my new favorite card, because I'm gonna run it a lot. Yeah, like I was thinking about maybe getting dry ice and a dry ice pot. Like there's pots for liquid nitrogen and for dry ice. Both kinds of pots can do both, but they're better for the thing they're made for. Liquid nitrogen, I was thinking about it, but I am pretty much at the point where I say it's not gonna happen for a longer time, because for liquid nitrogen you need like a DOR and stuff, and yeah, that stuff's expensive. You need to store it somewhere. My room isn't that big, or more like it's crammed. So, but like dry ice, you just put it in a box and you just get a pot. Still of plastic, if I can buy a new bottle if I need one. So yeah, and with an E-Power, this is not gonna be VRM limited. So I was thinking like, yeah, dry ice could be an option. Yeah, like it's not gonna be a I'm doing it now thing, but like I am definitely planning to do dry ice at some point. I mean, I'm also definitely planning on doing liquid nitrogen at some point, but that might be several years ahead. But I'm planning to do dry ice sooner than later, like maybe this year. Which, well, it's the 2nd of March today, is it? Yeah, it's the 2nd of March today. The year is still young. There's still time. But yeah, the video at this point is kind of long. So thank you all for watching. Hope you enjoyed, and I hope that next time you'll be seeing this card, it will have a functioning E-Power on it. And this one will just work because that capacitor is gone. So yeah, until next time, goodbye.